Today, we're going to pull back the curtain on the internet's hidden traffic cop. It's this unsung hero that's constantly deciding what data gets to you first online. It's called quality of service, or QoS for short, and honestly, it's the main reason our digital world even works.
So, you know that feeling, right? You're on a super important video call and boom, everything freezes, the audio gets all robotic, but then a second later, an email notification pops up. No problem at all. Why? Why does that happen? Well, it's not random. There's a system making that choice, and it's called quality of service.
You know, the best way to wrap your head around the internet is to just think of it like a massive highway system. And just like on a real road, an ambulance, with its sirens blaring, it gets to fly past everyone else. It has priority over someone who's just heading out to a restaurant. On the internet, some of your data is that ambulance, and some of it is just on its way to dinner. That's the big idea we're going to unpack.
All right, so let's start with the problem itself, the digital traffic jam. Because just like our highways, the internet gets clogged up, big time. And without some kind of system to direct all that traffic, it would just be complete chaos.
It's a pretty simple concept when you think about it. Your internet connection is basically a pipe, and that pipe only has a certain size. When you try to shove more data through that pipe than it can physically handle, you get congestion. This is the root cause of so many of our online headaches.
And this traffic jam, well, it creates all those problems we know and hate. That little buffering symbol spinning forever, that's called latency, which is just the time it takes for data to get from point A to point B. That choppy, garbled audio on a call, that's jitter. That means the data packets are arriving, but they're all out of rhythm, so it sounds like a mess. And what about when your call just completely drops? That's packet loss. The network literally had to throw some of your data away just to manage the jam.
So, how in the world do networks fix this mess? Well, that's where quality of service finally steps in. Let's break down what this thing actually is.
Okay, so at its heart, QoS is a whole suite of technologies that acts like a really sophisticated traffic manager. Its entire job is to look at all the data that's fighting for bandwidth and start setting priorities, making sure that the most critical stuff gets through nice and smooth.
Or, to put it even more simply, QoS gives your router the brains to stop treating all data like it's the same. It teaches the router to look at a data packet from your video call and another from a file download, and to understand that the video call is the ambulance. It just has to go first, period.
But how does it actually do that? I mean, it's not magic, right? QoS uses a very specific set of tools to manage all of this data flow. So let's open up the toolkit and see what's inside.
It really just boils down to three core jobs. First, it has to identify and mark the traffic. This is like giving our ambulance flashing lights so the rest of the network knows, hey, this is important. Second, it needs to control the flow of data, kind of like a ramp meter on a highway that prevents a jam before it even starts. And finally, when a jam is just unavoidable, it has to manage the queue, acting like a traffic cop who personally waves the most important cars through the bottleneck first.
Now, when we talk about controlling the flow, there are really two main ways to do it: policing and shaping. Think of policing as the strictest bouncer you've ever seen at a club. If the club is full, he doesn't ask you to wait. He just points and says, nope, you're not getting in. Any excess data is just dropped on the spot. Shaping, on the other hand, is more like a patient organizer. It sees there's a crowd, so it holds the extra data in a buffer and says, hey, just wait here a moment, I'll set you through as soon as there's an opening.
And all of this, all these tools, they bring us to the absolute heart of QoS. It all exists for one simple reason. On the internet, not all data is created equal. Some data packets are just way more important than others.
I mean, think about it. For a live voice call, that data has to arrive right now in real time. If a packet gets lost, you can't just resend it. The moment in the conversation is gone. You just get that awkward silence. Video is kind of similar but needs a ton more data. Without QoS, it just dissolves into a blurry pixelated mess. But in email, it can handle a little delay. Its underlying protocol, this thing called TCP, is literally designed to notice a lost packet and just try again until the whole message gets there. So, from the network's point of view, the email can definitely wait.
And you can see that hierarchy right here, clear as day. Voice traffic is at the very top. It is extremely sensitive to delay. Video is right behind it, and way down at the bottom is general data like emails and web pages, which are just built to be more resilient. This is the fundamental logic that QoS uses to make all of its split-second decisions.
So how does it actually create that priority? Well, one of the most powerful tools in the box is called low-latency queuing. Now, the name sounds super technical, but the idea is dead simple.
It creates a special VIP express lane just for that super-sensitive traffic. When a voice packet shows up, LLQ lets it cut the entire line and go first, before anything else even gets a look in.
Okay, so we've looked at the problem and we've peeked inside the toolkit that solves it. But what does all of this really mean? Why does this invisible system matter so much in our actual, everyday lives?
At the end of the day, it's pretty simple. Without QoS, the modern internet as we know it would just break. Every clear video conference call you have, every reliable online gaming session, every single time you stream a movie without it buffering, it's all possible because this system is working tirelessly in the background, playing traffic cop for trillions of data packets every single second.
And that really leaves us with a pretty fascinating question for the future. We built this entire system on the idea of prioritizing the few ambulances on the digital highway. But as we move deeper into a world of metaverses and real-time AI and who knows what else, what happens when everything starts demanding to be the ambulance? That's the challenge for the next generation of the internet. Thanks for diving in with us.